Okay, this is for Algebra 1, and this is for functional relationships. Start by looking at the menu for Elmo's Burger Place, and notice that you can go in and you can order based on the number, kind of like any normal fast food restaurant, and any of your orders comes with a choice of a side and drink. So, number 1, customers at Elmo's place their orders by number. Explain how this is an example of a functional relationship. You got to think back when we talked about functions and what is a function and what isn't. Remember that x cannot repeat for it to be a function. So the way that it is a functional relationship is that every number is a different meal. Okay? None of your numbers repeat, so it is a function. Number 2, how could the menu be rewritten and it not be a function? Could this present a problem with orders at Elmo's? And explain. If you were to rewrite it and give different meals to the same number. For example, a number 1 could be a burger, or a number 1 could be tuna. When they came in and ordered a number 1, you still wouldn't know what they wanted. So yes, it would cause problems. Number 3, identify the independent and the dependent variables. Remember, independent and dependent want words. And if you go back and look at what it's talking about, independent's the x, it's going to be on the left, it's the first. For this one, it is the order number that you use. And the dependent is the food or the meal that you're going to get. What are the elements of the domain and the elements of the range? Remember, domain and range want numbers most of the time. Now, this is an unusual situation. It's not totally mathematical. Your domain would be 1, 2, 3, ... 10. In other words, it's all whole numbers from 1 to 10. Your range, I'm not going to make you write this all out because it's just notes, but it would be each menu item, each meal that you could get. Burger, cheeseburger, tuna sandwich, BLT, those are all part of your range. Complete a mapping table using the following words. I've already filled this in so you can look at it. A mapping table is when you have the two circles and you match things together. Remember that the left side is our domain and the right side is our range. So for every cause there is an effect. Independent goes with dependent. Domain goes with range. If goes with then. Input with output. And x goes with y. So just take a minute and fill that in. Okay, using function notation. Function notation is when you say f of x is equal to whatever. So if a customer ordered f of 6, what would they get? They would get a hoagie if you look at the menu. So f of 6 equals hoagie. If a customer ordered 2 corn dogs, how would the waitress refer to this in function notation? So f of 9, then you would get corn dogs. So as function notation, f of 9 equals corn dogs. Why would it be important to use the correct function notation when placing orders for the customers? Well, if you used the wrong number or the wrong function notation, they would get the wrong food. What other 2 items are variables in an order? Remember, a variable is something that can change. So what are the other 2 things that they order that can change? And why are they considered variables? Well, if you go back, for $3.50 you get a sandwich with the choice of drink and one side. So your side and your drink are your other variables. And the reason they're variables is that you're going to get to make choices. There were several things you could choose from for your sides: fries, tater tot, salad, soup. And there were 3 different sizes for your drink: small, medium, or large. Okay, so now you want to get your yellow paper. This was our vocabulary sheet. The first word we're going to talk about is domain. And the top left, we're going to talk about a definition. We learned last semester that domain is the X values. Instead of doing level of understanding, we're going to discuss some characteristics. And so in the top right, the domain can either be a list or it can be given using the symbols, less than and greater than. An example of domain, if you're going to use a list, would be 1, 2, 3, 4. If you're going to use symbols, it would be 0 is less than or equal to X is less than or equal to 4. Remember, you'll use your list if they give you a table or if they give you a graph with points. You're going to use the symbols if they give you an equation or if they give you a graph with a line. A non-example is 2 is less than or equal to y is less than or equal to 8. It's a non-example because they're using y, and we know that y represents range, not domain. Your next word is relation, and the definition is not y values. Definition of a relation is a set of ordered pairs. A relation is a set of ordered pairs. For the characteristics, it can be given to you as a table. It can be given to you as a graph. It can be given to you as a mapping. It can be given to you as an equation. Sorry about the writing. A table, a graph, a mapping, or equation. So examples, this would be a set of ordered pairs. This would be an equation, and this would also be considered an equation. It's just written in function notation. A non-example is height of 4 centimeters. It means nothing. It is connected to nothing. It's just a piece of information. Almost anything we look at will be a relation in math. There are very few times that I will give you anything that's not a relation. So a function is when x does not repeat. They can give it to you as a set of points, as a table, as a graph, or an equation. An example is y equal to x, and a non-example is this graph. The reason it's not a function is that it will fail the vertical line test because it touches it once, twice. So it is not a function. Okay, what you need to be able to do here is, this is not in your notes, okay? This is just something that you need to understand that we talked about together as a class. You need to be able to look at a graph and know, is it a function? Use your vertical line test. Is there anywhere that I can draw a vertical line and hit this graph more than once? And there's not, so it passes the test. So yes, it's a function. The domain will be given using the symbols because it's a solid line. Start by finding the smallest x we ever had, which was right here. Then find the biggest, which was right here. So I know my domain goes from -6 is less than x because its domain is less than +6. Looking at my -6, it's a solid circle there, so I need to draw a line because it can be less than or equal. Looking at the 6, it's a solid circle, so it gets a line as well. The range goes from the bottom to the top, so go find your lowest point and go find your highest point. The lowest was when y was -3 is less than, is less than y is less than, the highest point up here was at 7. Look at your low point, it's a solid circle, so it needs a line. Look at your high point, it's an open circle, so it does not get a line. We've done this before, it's just been a long time. We're just trying to refresh our memory. This is called a mapping, and to tell if it is a function or not, you have to look and make sure to be a function, each one of the numbers on the left, which is your domain, can only have one line leaving. Each of these numbers only has one line leaving, so yes, it's a function. My domain, you just list the numbers, 4, 6, 8, 12, 14. The range, you just list the numbers, 5, 6, 7, 9, 10. We have a graph, so you're going to use your vertical line test. It hits it twice, so it fails, and so no, it's not a function. Your domain is looking at x. The smallest x we ever have was right here. And then it goes forever to the right. So 0 is less than or equal to x, and then you stop there because it keeps going. It never stops, so we don't have to put a stopping point. For your range, it goes down forever, it goes up forever, so your range is ARN, all real numbers. We have another mapping. Notice that we have 2 lines leaving the 12. This means no, it is not a function. Your domain will just be a list, 4, 6, 8, 12. Your range will be a list, 5, 6, 7, 9, 10. If they give you a graph with a lot of dots, you look and see, can I ever draw a vertical line and hit more than one dot? And I can't, so it passes the test. So yes, it is a function. To figure out your domain, it will be a list of all of the x values. So here's an x value at -6, at -4, -2, 0, 2, 4, 6, and 8. I took each dot and looked to see what the x value was for it. Range is the same thing, but you're using the y values. Anywhere that you had a dot, figure out what the y value was. So my range is -5, -2, 0, 2, and 3. That's functional relationships. If you have any questions, come see me during speed.